Welcome to the second part. Now we are in chapter 3 and then we deal with exploratory data analysis. Now, let me start loading, that is calling read table. So, when we call read table, we have this table xt, which is loaded, and then this table contains variables of different type. There are the variables which are numeric, there are the variables which are categorical, like gender and education. The difference between gender and education is that education is categorical ordinal, so A is smaller than B, smaller than C. On the other hand, gender is categorical nominal. There is no order among the modalities. Now, once you can show the first whatever rows of this table, and then the first thing to do is the summary. Let us see. The summary gives you an idea of the datasets understood. Right, for the variables which are quantitative and the variables which are of type date time, that deal with data. Now, surname, name and gender, they have been loaded as a cell array of character vectors. But of course, it makes sense to load surname and name as a cell array of character vectors, because surname and name can be everything. On the other hand, as concerns gender and education, then the number of modalities of gender and education is limited, so the variables are categorical. Therefore, the idea is, how do you set variable types? How do you tell MATLAB that certain variables are categorical? So the command to set that certain variable are categorical is called categorical. For example, xt.gender is redefined as categorical, and xt.education is defined as categorical. And moreover, categorical in this case is called with option ordinal is equal to true. The default is ordinal is equal to false, so you don't need to specify ordinal. But if you specify ordinal is equal to true, then you have an order between the levels, between the categories. So, now let us redo the summary after calling them as categorical. Redo the summary. So, you see now that this time gender and education have been defined as categorical. Now let's see xt, or let us see it maybe in, you see that the curly brackets have disappeared from gender and education. It's different from surname and name. They have become categorical. Now, the purpose of the next 10 minutes is to explore deeply what are the options of categorical. The first 5 minutes just to set up the problem. Now we have the file. Right.
The curly brackets because it's categorical or because it's ordinal?
Because initially they have been loaded as a cell array of character vectors. Initially, when you do this, when you load, then this is how they have been loaded, as you see. This is the default. It doesn't know that it is a categorical. It doesn't, for him, F, M is like surname. So it assumes that the field can contain any combination of characters. On the other hand, gender contains just M and F.
Yeah, that is categorical.
Right.
But it cannot be ordinal.
Gender is not ordinal. There is not ordinal between M or F, okay? This goes without saying, especially in this period where you must be fully compliant to the rule, absolutely. Don't say that there is an order between these two levels, these male or females, right? On the other hand, education is ordered because, I mean, bachelor degree maybe is smaller than master degree, smaller than PhD or whatever. In this case, there is an order. So now, let us explore it. So the file that I'm using, that I've pushed, is called category intro. No, it's not this one. This one is the Italian version. So it is okay, category. Okay, this one. Now, okay, this has been created with the Copilot. So a category, a string array. Okay, so we start with this. So this is 1 times 10 times 10 string array. Now we have the categories. The categories as just these 4 CTGs. These are the categories. So one thing is the string array, then each category can be repeated how many times as you want, and the other thing is the unique categories. Now, if you do C, if you do categorical C, then you transform this variable into categorical. When you do tabulate, what is the order that it takes? If you do, you transform a string array into categorical. There are different categories. Now, when you do tabulate, what is the order? The alphabetical order. It doesn't know anything, so it takes the alphabetical order. You see, bachelor, high school, master, and school leaving certificate. This is the alphabetical order. So if you call categorical just one input argument, then it does all the defaults. And the defaults, the levels are in categorical order, in alphabetical order. Now, you specify categorical now with 2 input arguments, not only C, but you also provide the categories. You see that this has 2 input arguments, right? If you have these 2 input arguments, then the order in which the categories are presented is that of the second input argument. So first I have school leaving certificate, high school graduate, bachelor's degree, and master degree. Okay? So if you want that you have a particular order among the variables, then you specify the categories in the second input argument. Now, let us see now if you do this. You specify just this categorical array, and then you say ordinal is equal to true. What do you expect that MATLAB does? Then here you say, I want to have the order between the categories. So far, the order was, well, there was the order just for display, but the minimum of cat is not defined. Look, the variable is not ordinal, so you cannot find the minimum. It is not ordinal, clear. So if you do this, if you just give ordinal is equal to true, given that you did not specify the categories, when you do minimum and maximum, what do you get? You get the first in alphabetical order and the last in alphabetical order. Let us see. You get bachelor and school leaving certificate. This is the alphabetical order that it takes. Right. Now, on the other end, see this syntax. You give C, you give the categories, and then you say ordinal is equal to true. Now, this time, the minimum will be the first of the categories you supply, and the maximum will be the last of the categories you supply, not the one in alphabetical order. So you see, now, if you do this, you have school leaving certificate, which is the first, and then master degrees, which is the last, because the categories were this. So this is the minimum and this is the maximum. Right. And can you also do the median of vector C? Absolutely, yeah. Of C, not, but because C is a string array, but of cat, you certainly can do the median, because that's an ordered categorical vector. And so it has the median and it has the quantiles. Right. One thing. If you have now this categorical vector, cat, and then here it says the second element is equal to, you see, this has never appeared before. You do the second element, now it is just in this list. Can you say that the second element is this one? Not at all. You cannot add an additional category. Just, okay, if you can choose just among those or those that you already have. Otherwise, if you want to add a category, you must have a special function, which is add cats. Add cats, and if you want to add this, add cats, add categories, and then to this categorical array, and then which one would you like to add? This one, and then he say, in which position do you add it, given that it is ordinal? After or before? You see, before school leaving certificate, for example, but everything is, you see, before, and then comma, and then everything is fully guided. So you don't have to type anything, because everything comes along and then you have the auto-completion. So don't do, so here it says that before school leaving certificate, I want to add, okay, look, in fact, this, okay, I want to have this additional level. He said, now, let us see, can you understand this message? Then look that you did not modify the original variable, You did not modify the original one. But in order to modify it, then you have to say that cat is redefined as. And then in fact here I put a new cat. Let us say new cat. Say, look that you didn't put a variable. Now it says cat2 is equal, new cat 2, new is missing the new cat 2 is equal, and then I also find NNN, right. Therefore, if you call categorical just one input argument, it becomes unordered and takes the alphabetical order. You have to specify that is ordinal or not ordinal, but you also have to specify as a second element the order of the levels. Right, that's the idea. With that said, therefore, when we load the data, we start doing this. We start defining the variables as categorical. gender, and you see, probably here A, B, and C, the levels are unnecessary because it is already the alphabetical order, so it is not necessary. Just for clarity, here I put A, B, and C, but it is unnecessary. Now what you want to do, you want to do some computations about the quantitative variables. So before going on, let us remember that categorical is a data type, an atomic data type. Now we still have to see date time, duration, and calendar duration, and then we have seen all of them. Before moving on, for example, you suppose that you do not remember how the MAD is computed. Right, you know what is the MAD? Is the median absolute deviation from the median. Is a robust measure of dispersion. But suppose that you don't remember how it is computed. Okay? So, you have, then you, for example, you say GUI, MED, and then you supply the vector that you like, whatever, the number that you like, and then here you find the GUI, which tells you how the index is computed. All the calculations that need to be found in order to compute the index, right? So this is the median of the absolute deviation from the median. So first you compute the median. You sort the elements. So you see, this is the notation. Xi is the unordered elements. X in parentheses are the order statistics. And then here you compute here 3, 4, 5, 6, and then you compute the median is the mean between the one in position 3 and the one in position 4. And so you get to the median. Then you get to the median, then you have the deviations from the median. So this is minus 17 because it is 2 and the median is 19. So you get minus 17. Okay, then you take this number in absolute value and you order them. You see there is a subscript in parentheses side. You order them, and among this number you take the median. This is the MAD. So it's a robust measure of variability of dispersion. Now, if why is it robust? Now, suppose that 56 is replaced with 56,000. 56,000. The same. Because it's the median is not affected by this big number, and the median of the absolute deviation from the median remains the same. So this is a robust measure of dispersion. Or for example, you remember the formula to compute the skewness or the kurtosis? Or do you don't? Okay, so you do. Instead of GUI MAD, GUI skewness. And then here it tells you all the computations that you have to do. Right? You put the vector that you like and then it gives you all the computation. So this is, yes. Well, with the pen you take a lot of time, to do these things by hand or by, okay, you know. And then with these indexes, you can have the biased or the unbiased version of the index. Right. Now, so, therefore, keep in mind, so you did GUI and then you find all of them. Right. GUI, for example, GUI quantile of xt dot education. education, the quantile 0.7, and then tells you how it finds the quantile for a categorical variable. You see they are ordered. So 0.7. Here there are 22.3%, something like that, which have level A. There's a level B, which go up to 58, and then quantile 0.7 is associated with level C, right? So everything here is clickable, so you can right, so you can hide or show the things. Now, you understand the syntax when you extract with the round parentheses or with curly brackets. So once again, if you extract with curly brackets, you just have the numbers. If you extract with parentheses, you have a subtable, right? So, format bank, for example, well, then you compute the mean, the arithmetic means. Okay, let us give the interpretation of this 2546.65. What is the interpretation of this number? If all people inside the sample had the same level of wage, this is the level of wage that each person would have had. This number times n is equal to what?
The average.
No, this number, this is already the average. The average is the total sum, of course. Right, so is the unique number which leaves the sum unchanged. If you do n times the arithmetic mean is just to do the sum. So you replace all the values by a single number, and then you multiply by n. So, and then sample medians. Okay, you do the medians, and then for the table, and then works. You do the standard deviation, and then look at the coefficient of variation. Then you divide the standard deviation by the means. The coefficient of variation is therefore sigma divided by m. This is the coefficient of variation. Okay, this one. Right? Why do you do it? Because here, when you have, what is the variable which has the largest variability? What is the variable that has the largest variability? Of course, no, you cannot say it. You cannot say it. That's the reason why you do the coefficient of variation. Because if you multiply by 100, then sigma increases by 100. Or if you do in euros, if you do in dollars, then you have a different value. Right? But if you divide by and then you compute the coefficient of variation, now these numbers, you can compare them. So here, then the largest variability is for seniority. Right?
Variability means in terms of their value, right? In terms of
Exactly. So they don't have they are pure numbers, these CV, because you have euros divided by euro and then they cancel out. You have dollar divided by dollar. So these are unit-free numbers. Now, skewness. You see that so far the input was a table. But when you do skewness with the input as a table, XTQ, it does not work. It says that to compute the skewness, you cannot have an input as a table. Therefore, what do? You provide an input as a double. And then with array to table, you convert it to table. That's it. Right, so you compute, you see, you compute the input as a matrix of doubles, and then you convert it. Same thing for kurtosis. So you all know what kurtosis is. You know that skewness is has to do with the shape. This is positive skewness on top, this is negative skewness at the bottom. And then for kurtosis here you want to understand whether which distribution you have. Right, in finance generally you have so-called heavy tails. You have leptokurtic distributions. You have heavy tails, tails that are bigger than normal. So this is actually traditional definition. Anyway, leptokurtic heavy tails. In fact, the student T distribution, they are really heavy tails. So these are the MATLAB function. And now we have to compute the frequency distribution. So this is the purpose. So you can do it with different ways, and now we are going to review them very quickly. So let us call this frec. So, okay, you have this vector x, which has 1000 elements, and then you have to put them into separate bins. Therefore, or what you can do, let us see the function histogram. Let us see function histogram. Can you read this help? So, for example, if I want to have the histogram and I have to put the classes of the histogram of the wage, and my classes go from 1000 to 5000. What do I do? What would you do if you land in the help function? Then you see histogram n bins, for example, if n bins, the number of bins specifies the number of bins. Or in this case, there are edges. So edges, the vector which has the edges, right? So now just let me, therefore, you see, this is the call to histogram with all default arguments. This is the call to histogram with the 10 classes, you see. This is the call to histogram with the classes that I define, this vector. Therefore, the second class here will be what? No, the second class will be from 2500 to 3000, the second class. Let us see. Right. No, the second class.
500 increase.
Sorry? The second class is from 2500.
It goes by 500.
Right, it goes by 500. Right, yes, exactly. Or otherwise, look at this syntax. Can you understand it? You see that here it doesn't have xt.wage. So it has how many classes?
How many big coins?
You see, these are 4 elements. 4 elements, therefore 3 classes. 3 classes, and therefore 3 bin counts. You see. See, 3 classes and 3 bin counts. You see? So you see, the first is 20, 10, and 12, right? Okay? Can you understand the syntax, eh? So you see here, it doesn't have the input which is the original vector. No, just what are the classes and what are the bin counts, that's it. You see, that's the difference. And this is what is telling you in the help here, that you can call histogram in this way, or you see that here it doesn't have x as input.
Yeah.
So that's how you read the help. lets you understand how to use the function. And same thing here for C. What is the difference from X and C? Is that X is a numeric and C is a categorical, right? With bar for each category in a categorical array, right? Very well. And now, if you do this call, H is equal to histogram, then it has an output, which is H. For example, here, if you call it this way, then it has an output which is H. And then H has all the properties, and so you can change the width, the face color, and whatever. You can do whatever you like. Z, you access this handle, right? Or otherwise, it is an object, right? It is an object. You see, show code, or what? Well, you see. And this current axis, or for example, put the label here or whatever, but it gives access to this object. This object has a series of properties that you can change, right? And this is the... Okay, now, in order to have... So you see, this is a vector with 1000 elements. These are the bins from minus infinity to 2, the second class from minus 2 to 0, and so on. And you see this H, and then when you call histogram, H, and then H dot, you see, dot values. These are the frequencies for each class, right? Or you can do also with these counts. With these counts is the same thing. Is count X and bins the same thing. Or and then later you create this table which has the labels and so on and so forth. So first you find the numbers and then you have the table. Right. Now let us see what discretize does. Discretize with the two input arguments. So if I supply the bins, the vector of the numeric bins, then if I supply these numeric bins, class membership here for the first is 3. Because why? Because the first element is 0.66 and 0.66 belongs to the third bin, right? Can you see it that 0.66 belongs to the third bin? First bin, second bin, and third bin, from 0 to 1.5. Therefore, the element is 0.66, belongs to the third bin, and so you have 3. So it transforms the original X into another vector which has the number associated to the bin it belongs to. Right? So when you do tabulate, then you do tabulate, or you show the first 5 member, tabulate, and then you have 1, 2, 3, 4. This is if you call discretize just with 2 input arguments. If you call discretize with 3 input arguments and the third argument is categorical, look what you get. That the class membership is the class with the proper label. So you see that it is 0 and 1.5, 0 included and 1.5 excluded, right? With the 3 inputs. Or then when you do the tabulate, this is precisely what you get. With 4 input arguments, you can specify the labels that you want to have. So you can put personalized labels. Right. So this was something very, very easy. Now, okay. Now we want to do this analysis. We want to do the boxplot separate for male and females. And then we want to label the outliers.
So those are the outliers?
Right, right. The outliers are the points falling beyond the whiskers of the boxplot.
It's like machine learning.
well, actually, now what is called machine learning is really statistics. Now it is amazing because all the world wants to do my job, but I've been doing these things for the last 30 years. Now you call it machine learning, you call it AI, but now all the world wants to be a statistician. I've been doing these things for the last 30 years. Now now you say statistics, now okay. That has always been my job. Now all the world wants to do my job. It's incredible. Incredible. So let us comment on this plot before seeing the details. Okay, the distribution is right or left skewed. There is a positive or negative asymmetry in the wage. Surely positive asymmetry. The length of the right tail is longer than the length of the left tail. So you see, the distance here is greater than the distance here. And then the outliers are on the right-hand side of the distribution, not on the left-hand side. So you are in the situation that we have seen before, no, not here, but here. You see. This is the thing. And this is where the mean is greater than the median, is greater than the mode. Now, so we are going now the median, so the central segment is the median, this is the third quartile. And this is the whisker, and then these are the outlying units, distinguished by gender. We want to do this, and we also want to do what now is very common and the violin plots. Maybe with the distribution of points inside. Right, these are the violin plots. Now, okay, so we load the file. We divide the figure into two panels. You see now that with this code subplot 1-to-1, I'm creating this. Therefore, I'm divided into two panels, and I'm putting my plot into the left panel, right? So just to make sure that you have understood, subplot, for example, 2-to-4 divides the panel into the window, graphical window, into 4 panels and puts the output into the 4th. And then here maybe you put plot 110 or whatever. Right. Then you do subplot 2-to-2, and so it is created here, and 2-to-3 is created here. Right. So you have the subpanel. Therefore, the idea is create divided by graphical windows into two panels. Then you put the boxplot, and then you have function add to boxplot. Add to boxplot enables you to have the labels, right, of the outlying units. Note that here add to boxplot is the variable you are considering. If you put these curly brackets here, if you put the curly brackets, you just extract the numbers. You don't have the row names. And so, if you do this thing, what do you get? Instead of the row names, you have just the row numbers. Of course, it doesn't have the information about row names. So, if you supply a table, it gives you the label of the row. If you do not supply a table, it gives you the number of the row. So, and then what is the syntax of boxplot? Boxplot of a variable and then divided by a particular value of gender. So you see, x times gender. Then quantiles. Quantiles, you want what you want to do. You want to do let me give you the preview of what you will have to expect. So you have to compute the quantile of the distribution of male and female. Now, can you interpret 2453? 55% of the female of the sample have a salary which is smaller than 2453, and 45% have a salary which is greater, right? From this plot, what do you see? That the quantiles of the salary for men are uniformly above those for women. That was not evident from the other plots, but from this plot it is, apart from this intersection. Then you see that the red curve is always above. So each plot always reveals different things. Therefore, here what do we do? In order to compute the quantile, but you don't compute the quantile for all the population. You compute the quantile for a subset. So you have a Boolean vector, which is equal to 1 when gender is equal to m, and then you have the quantile, the vector of quantiles, and then you do the job. Right. Something which is really very, very easy. Same thing with the violipnplots, then you can have the file later. Now, confidence intervals. You all agree about the expression of the confidence interval? You have already seen it several times, do you? Or not? Right. So, here, what we want to do? We want to do the confidence interval of the wage as education level increases from A to B to C, right? And what is the interpretation of this plot? As education level increases, wage increases. But they overlap in the sense that here there are persons who have A and then gain more than those who have B. But generally those who have A have a level of wage which is much smaller than those who have level C. Then if you keep going and then there are the professor, then it goes down, you see. If this is A, B, and C, and D, because beyond a certain level of education, then you are not interested anymore in money. That is always the case. So beyond a certain level of education, then it is knowledge, which is more important than money. It is something which is strange. Now, how do you do it? The function is the input file that you have to place, grp stats intro. Okay, so we load our dataset. Now let us see the help of grp stats. Let us see. This is summary statistics organized by groups. And let us see this one. This one, you see that, can you see this help? This says that if you call grp stats with the three elements, with the three input arguments, where this is a vector of a matrix, this is the grouping variable, and this is the 1 minus alpha % of the confidence level. If you call it in this way, then plots the group means in the numeric vector grouped by variable by the variables in group, and then at a certain confidence level. Therefore, you see the syntax. grp stats x dot wage, you take the wage, the grouping variable is education, and then you have a confidence level. Right? So you define this one, and then this is what you get. Where is it? Here it is. Okay? And the line here connects the group means. Right? Now, if GRP stats, this compute the summary statistics, you compute the summary statistics as the second input argument is the overall sample, and in this case the second input argument is empty, or otherwise you can put a grouping variable, so summary statistics, for example, male and female. For example, this is the syntax in order to compute, let me see. This is the syntax in order to compute mean, standard deviation, confidence interval for wage, seniority, and so on and so forth. Let us see some, maybe some online. Oh, so GRP stats. GRP stats. So the input table, then the grouping variable. For example, the grouping variable, we want to do it by education. For example, by education. Then, which stats, which statistics you want to see? For example, I want to see the mean and I want to see the standard deviation, right? And then here, which variables, for which variables I want to compute the statistics? I want to compute the statistics for wage and commuting time. You see that everything is auto-completion. Can you follow this syntax? So group stats, then for each level of education, you compute the mean and standard deviation for which variable, for wage and commuting time. Right, something which is absolutely very, very easy to do. Okay, then once you have, for example, grouping variables can be both gender and education, you see. Then you can do a bar plot for each level of gender and education. Now, let me say something about the difference between GRP stats and GRP FS. Now, GRP stats. Now, suppose you want to have the mean, median, skews, and kurtosis for all the variables of the Cities Italy dataset. You see, it computes everything. But it computes everything, but the output is almost unreadable. You see, everything is one line. So certainly is much better to call GRP stats FS. This is precisely the output you want to have, don't you? This is the output, GRP stats FS, which is the function that we have created in order to give you a very readable output. So you have mean and median, robust and non-robust, standard deviation and MAD, robust and non-robust, skewness, non-robust and robust. Or, for example, if you add a grouping variable, so you add zone, the mean and the median, and then it has the same, say, mean and median for the two zones of Italy. Or, if you use the input plots is equal to 1, you can see in output also the confidence levels. And these are the confidence interval of added value, deposit, pension, unemployment for the two areas of Italy, the north and the central and south part. So you can see that these two areas are completely different. So you see that there is no intersection between the added value in the north and the added value of the province of center and south. Maybe the only one intersection is bankrupt. Okay, the bankrupt in the north is the same as the bankrupt in center and south. For all the others, or maybe bills overdue. Bills overdue no, is greater in the south. Unemployment is much greater in the south of Italy, no doubt. Export is much smaller, but they intersect a bit. So you have as a benefit, if you use GRP, stats, FS, the additional plot. Now, pivot table. You all know what are the pivot table, do you? Okay, now we see 10 minutes how to compute them in MATLAB. So, if you do a new live script, and then first we load our data. First, let me load our data. Script here. Okay. See what happens if you start write piv. You see that you have pivot table. Pivot table. Okay. If you click on pivot table, and this is one of the amazing things of MATLAB, it automatically inside your code you have an interface where you say input table, select, and then I have X. Then what do I put in the row? In the row maybe I put gender. What do I put in the column? In the column I put maybe education. And what do I put inside? Here maybe I put wage, and then the value. Let me resize it a bit. Input table. Okay, and then you can also have show code. Then it gives you the code. You see that this is the preview of the output in line or below. You see, then input table or whatever. Let us do. You see, then you have what you put in the rows, what you put in the column, and then what you put, for example, inside. Instead, count, sum. What do? You put the maximum inside, maybe for each combination. I know here I put gender and gender, and then education. Right, and then you see the output. So this is the pivot table, which has gender in the rows, columns, education. Inside there is the variable wage, and the method inside is the maximum. So you have the maximum value of wage for each combination of gender and education. Right? Now we wanna do this, and then we remove this task. Remove this task. Where is it? Remove task. And then now we want to do everything from scratch. Remove all output. Copy output. Where is remove all output? Okay, let me run it. Okay, so it goes away. So the idea is that if you do pivot and then you take the input table, then you see what is in the rows. For example, rows. The rows, and then you see, for example, gender. Then what is in the columns, and then you take columns. The columns, okay, so education. Then what is the data variable inside? The data variable inside maybe is wage, and what is the statistics inside? Method, and then you see the statistics. So it's something which is okay. Good morning. It's something which is absolutely very, 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 very easy.
Vuoi che ti faccio vedere? No, vuoi che ti faccio vedere? Fatti la presentazione per la presente. Vuoi che la faccia dopo questa lezione o vuoi che la faccia domani?
Okay. Now, so in pivot table you have what goes in the rows, what goes in the columns. Now, row label placement. Let me see what row label placement is. Labels are row names or not? Let me see. Let me see the difference between this pivot table here, where you have 4 columns, or where you say row label placement, row names, and then let us see what it does. You see that it creates something which has just 3 columns. You see that before it had 4 columns, right? Then, okay, if you do something like this, then MATLAB automatically breaks the code into 2 lines. Okay, now let us do one example of a difficult pivot table. For example, text, pivot table. In the rows, gender and wage. Gender and wage. In gender and wage with the 5 classes. In the columns, seniority. Seniority with classes, I don't know, 0, 20, 45. Okay, and inside, okay, nothing. Okay, now let us code. So pivot x rows, gender and wage. You see there are 2, not just 1. Right, of course, gender and wage. Right. However, now rows bin method. How do you bin them? Yes, so the first gender is already categorical and therefore is none. And the second one, 5 classes, and so 5. Then let us see if it works, because everything has to be checked. No, does not work. So let us put it using this cell array. None and 5. Let us see. Yes, it has been, he wants to have a cell array. Then columns, then you have seniority, columns, seniority, and then columns bin method, for example, these classes, 0, 25, and 45. Don't you think that is something that is really incredibly easy? Incredible, eh? Something which is, I mean, with the auto-completion. Yes, please. If we don't put if we don't put what?
You can say to MATLAB if you want to use superior edge or inferior edge.
Ah, right. You see this thing? Yes. These are classes which are closed on the left and then open on the right, apart from the final one, which is open and closed. Right. Include edge, and then you see left or right. It's amazing, eh? Include edge, and then right if you want that the classes include the right element, the element on the right, the superior element. Okay, let us do this. You see. Then let us also do row label placement. Row names. If I do row label placement row names, what does it do? You see the very good thing. You see the labels on the row names, M and F combined with the classes. Exceptional. And okay, so suppose that in the columns you want seniority, and then you want education. Education and seniority. So columns bin method, therefore columns bin method must be for education none, and for the other is this vector here. So here I've put two criteria on the columns. You see, columns, education and seniority. Columns bin method, none, and then 0, 25. Okay, none, of course, written in this way. Now, where is education and seniority? Education and seniority with curly brackets. Then they must have a single quotes. Okay, must have a single quotes, and that's it. Look, you see that I've classified according to education and then the seniority. Now you see that also now we'd like to have A025, A2545, and so there is this additional option which is called output format, maybe output format flat. Look what it does. It creates the labels for the column that we like. A 0.25 instead of nested tables. So something which is, incredibly easy. Because just with 10 seconds with the auto-completion, you really can do everything. So come on, there is no competition. So with other software, and there you see the difference between this option output format flat, this is the output, or nested table. Now we see what is the problem. Now we have to reshape the data from the top to the bottom. You agree that the top already has all the numbers, all the 6 numbers. It's just a reshape because these numbers have to be put here in this way. Okay. Then let me see timetable. Okay, so let us suppose that we start with this, which is this X tab. So we start from this, right? And this is a feature that is possible with the pivot table just from MATLAB 2025A. Last year did not exist. So it's pivot. So you see, this is the input and the output is this, right? So pivot of X tab, which is our pivot table, and then here rows becomes gender, columns education, okay, method is equal to none. Right. So therefore, don't do, I mean, the input is not that something that has to be put into bins. No. The data simply have to be reordered. So method, what did I do? Data variable with method, data variable, right. Data variable is missing. Here it says, look that you specify method, but you didn't specify data variable. You want to have the data variable, write the data variable. Data variable, this one. Data variable is what? What is the data variable that has to be selected? Tell me. Mean wage, of course. Mean wage, because I start from this table, and so this table has a column which is called mean wage. Okay, and then here you do row label placement, which is equal row names, and that's it. So our reshuffling is absolutely unbelievably easy. Now, let me see what you do when you, once you have created these levels, then you can create for each level of wage or education or the violipnplot called to boxplot or called to box chart, right. However, now, let us go to chapter 4. Suppose that you have to load the data from a web page, okay? So we go here, this is the web page, so this web page has got all these numbers. These numbers have to be read into MATLAB. So this is the encyclopedia of integers numbers, of integer sequences. There is a word of these people who study the integer sequence. They even have the encyclopedia. So you could not even imagine. You could not what there is inside, but all the languages. This means that in every country there are people who study these things from morning to evening and keep giving contributions. However, this is one of them, one of the integer sequences. Let us see what you can do. Okay. Web read. That's it. And then string to num, and then you transform it to numeric. Okay? Nothing to explain. Web read reads everything. Now, as a preview of now, importing data from a GitHub page. Because this is every year, this website, this is our most important financial newspaper. It's Sole 24 Ore. It's like for people in USA, it's like the Financial Times. Here we have Sole 24 Ore. And then it has all the data about the quality of life of the provinces, of all provinces of Italy. From 2020 up to 2024. So each one has a GitHub repo, right? And then here, and this is the address in order to clone the repo. Qualità della vita means quality of life. Now, let us see, sole 24 ore. Okay. So, first thing to do, therefore, is to clone the repo. Clone the repo, and then this subfolder is created. Then you load the data, and then here you load the data. Look that when you do the read the table, here you given that you are loading a file which is in a different folder, you have to give the relative path. That must be clear. Because if you do read the table, file name, of course it cannot find this file because this file is inside this subfolder. So you see the relative path, and then you can see file sep. File sep is the symbol of file separation. If you have a Mac, file separation is the slash. On the other end, in Windows, file separation is the backslash. So this code works independent on the fact that you are using a Windows or a Mac computer. Right. Now, let us see this X22. X22, let us see it. How the data are organized. Here there are the name of the province. Here there is the value of a particular variable. Then the variables are not put one after the other on the columns, but you have the second variable is stacked. The rows are below. You can see that this is another variable, and this is the value, valore is the value. Then you have variable 2, then you have variable 3, then you have another variable. So now what you want to do, you want to put all these variables, each variable on a separate column. You see the problem? Can you see? Here, the size is 9,631. 31 is mysterious. Well, it's not mysterious because if you go at the end, okay, there is some rubbish. So there is none, so the last row is rubbish. So it means that I don't know how they have put this file, but every year there are mistakes in this database. Yes, this is always the case. And then we will see the mistakes of year 2024, because this is year 2022. Therefore, here it is clear that what you have to do here, you have to, let us say, this is the Y2, this is the table on the other end that you want to have, where you have each province and then all the variables, you see. But on the other end, before, you had something like this with 9,631 rows. On the other end, you want to have something which is 107, because 107 are the Italian provinces, and 90 because there are 90 variables. So you wonder, how do you do in order to change from X22, which has all the variables, one on top of the other in the same column, to a matrix where each variable is on a separate column, right? And once again, is just exactly what we have done before. So pivot, all the rows apart from the last. Can you read this syntax? All the rows apart from the last. Rows, denominazione corrente. Well, rows, here you want to put denominazione corrente. This is denominazione corrente, where okay, yes, this is the name. On the rows, you want to put the name. Okay, here it is. On the rows, you want to put the name. On the columns, you want to put the variable indicator, and then data variable valore. And method none. And row label placement, row names. This is exactly what we have done before. Exactly. Now, load the data from 2023. Here everything is absolutely fine, and then you can create the pivot table Y3 without problem. Then you go to 2024, then you clone everything, and when you read the table, when you read this table, instead of having 9,630 rows, it has 5 additional rows. See, but why? But this is our official financial newspaper. These are the data put on GitHub. These are data that should be doubly checked. Well, however, if you do unique rows, you find that there are some rows which are duplicate. Some rows which are duplicate, and then you end up with 9,630. And then here, some 2 lines of code in order to find the so-called duplicated rows. And these are the provinces that have been duplicated. Just to show you that in MATLAB, knowing the data are wrong, 1 line of code, you can immediately detect what is wrong, and you can still go on.
Can we just have functionality like on the sort of not nearby that removes the
Right. In fact, and unique does it. Unique does it. Unique called with second number rows, so because it called on a table, so rows that are equal, you just put 1.
like distinct,
Sorry?
like distinct.
Yes. Exactly. Okay. Now, now something about the timetable, but before going to a timetable, at least I want to tell you something about this website, Fred. You all know the Fred website. I mean, of course, some of you already know it. It contains 80 millions of time series. 80 millions. 80 millions. So, of course, there are all the Italian time series, okay? So, consumer price index Italy. Okay. But just tell me, can you tell me a country or a consumer price index? Tell me a country.
USA.
It is clear that there is. Here I want to show you, a country that,
Taiwan, Pakistan.
sorry? Pakistan. That I don't know. Ah, yes. Yes. Right. Therefore, when you click on it, you see it says that the series, and then here this is the name. Right? This is the name of the series. You do Ctrl C, consumer price index for Pakistan, look. but these are real data, eh?
Yeah, sure.
These are real data. So this is the name of the series, and so let me do read import personalized. So let me see where it is. The code that I have to search is Fred. No, it is MATLAB, and then it is in imports. And the file is Fred. Okay. So this is the first line, always the same. You establish the connection to the website Fred, right? Then fetch C, and here you put this string here, right? Okay, that's it. That's it, right? You see? Now, stack the plot, which is the plot for time series of TT. Right, and now you have it in MATLAB. Okay? It's amazing, eh? Is amazing, this thing. So Fred, and then you establish the Fred connection. You can do it with Bloomberg, of course. With Bloomberg you pay their financial data, and I have tried to ask them, look, that I'm a professor of statistics, I want to have 1 year free trial so that I can give it to my students. Then they told me, no way, here if you want you have to pay, we don't care at all if you are a professor, not a professor. So it is clear, therefore, what you have to do with this 80 million series. And what is incredible is that now it is synchronized. So tomorrow, if tomorrow they upload the new data, then you get the new data. Okay? Okay, I think this is also because I'm really also very, very tired, and really, at least now I have to eat something to get a rest. Okay, thank you very much, and see you next week. No, before next week, see you tomorrow. See you tomorrow at 1:30 in the labs, if you like. Can we upload? It's not been uploaded yet.